Hi, Year 11. Yesterday or last lesson, I was getting you to look at just basically putting tables of values together, plotting those linear functions. Now I just want to see if I can get you to shortcut beyond the table of values and maybe just use these couple of bits to inform how you're going to plot the thing. Now, yesterday we're looking at the main thing that actually they all reformat into this sort of known format, the equation for a straight line. The m is a 2 in this case, and in this case. It's a -1 in this case, it's a -3 in this case. The m is the slope of the line. And the c, or the gradient I should say, the c is, I called it yesterday, a starting point, but it is actually that point on the y-axis that this line touches. Now the cool thing about plotting a line is you only actually need 2 points known to actually create a decent line, or any line. So I'm going to start with the top one, and I'm not going to put a table of values together. I'm just going to start with that starting point. That C value is my starting point. In this case it's a +1, a +1. So when I go to +1, I'm going to put my cross on there as you go, 1 point plotted. Now I'm going to then go on to do a slope, a changing rate of 2. We saw yesterday a 2 here effectively means it goes up 2 and across 1, up 2 and across 1, up 2 and across 1. So let's have a look at that. If we went up 2 from here, 1, 2, across 1, I get myself a point. Again, from this new point, if I go up 2, 1, 2, across 1, I end up here. And if I go up 2, across 1 from there, 1, 2, across 1, I'm about here. Now, if I was using a beautiful grid like you guys will be, I'm sure that'll all line up beautifully. The case is, it's going to be only half reasonable here. Let's just try out. So here we go. And you'll notice I rule all the way through my grid, okay? Because lines are effectively infinitely long, and so we just make the thing as big as the grid. I can actually write y equals y equals 2x plus 1. That's the name of that line, so I'm going to put its name right by it. So that's that one done, 2x plus 1. Let's try y equals 2x minus 1. Minus 1 is my starting point, so I go down to -1. Boom, there we are. -1 is my starting point. And then I'm going to do the same thing. It's a +2, that means up 2 steps across 1. 1, 2, across 1. Bang. Up 2, 1, 2, across 1. Bang. Up 2, across 1, 2, across 1. Bang. And actually, we should find that this one, if I've done reasonably well at it, should generally be, let's get that just right, y equals 2x minus 1. These two lines are in fact parallel because they happen to have the same gradient, which means the same slope is definitely parallel. They've just got different points at which they go through the y-axis. Awesome. Okay, the ones below, we're going to quickly plot those. This one is a starting point of +5, so I've got the +5. There we go. Bang. And it's a downward -1, so it's a down 1 across 1, down 1 across 1. So that's cool. I'm going to try that out starting at 5, down 1 across 1. Boom. Down 1 across 1. Boom. Down 1 across 1. Boom. And again, once I've got a few plotted, I don't really have to get many more. And it should turn out a little bit like that. Try and make it a fairly big one. And I'm going to put my label up there. Y equals -x plus 5. Awesome. Last one. I'm going to plot that reasonably fast. Minus 3x plus 5. Y equals minus. It's a downward slope of 3 down across 1. 3 down across 1. Negative 3 means 3 down. Plus 5 is my starting point. It's the same starting point, but now it's dropping down, not dropping down 1, but dropping down 3. 1, 2, 3 across 1. 1, 2, 3 across 1. 1, 2, 3 across 1. You can see it's really dropping down fast. Hopefully we'll also see why we don't very often have gradients on our graphs that are much beyond the 3. Because they can't start getting crazy steep and become hard to plot, gradients of 5x, really, really steep. Anyhow, I'm going to leave that one there, guys. Let you get practicing really, if you can, just shortcutting using your starting point and your slope to try and pick out some coordinates without having to generate a table. All right, cheers, guys.